There is a hole in the ground in Staffordshire, near the town of Dudley, where in 1712 somebody built a machine that should not have been worth building. It stood over a coal pit, a brass cylinder, 21 inches across, just under 8 feet tall, 12 strokes a minute, 10 gallons of water on every stroke, lifted 51 yards up into the daylight, and it burned coal at a rate that anywhere else on Earth would have ruined the man who owned it.
The man who built it was Thomas Newcomen, an ironmonger from Dartmouth in Devon, and what he had made is called an atmospheric engine. Steam fills a cylinder, cold water is sprayed in. The steam collapses into a vacuum, and the weight of the air above the piston shoves it down. That is the whole trick. It is also, in energy terms, close to a catastrophe. The engine threw away almost all the heat in its fuel on every stroke. Well under 1% of it came back out as work. Put that machine in a French textile town, and it is a bonfire with a beam on top. Put it in London, where coal arrived by ship and cost several times what it cost at the pit, and it is still a bad idea. There is exactly one address in the world where its worst flaw stops mattering. On top of a coal pit, the fuel is already at your feet, in the form of small, dirty coal the pit could barely sell. Hold on to that. It matters more than the engine does.
So why was there a pump at a coal pit at all? Because Britain's pits were drowning. British coal had two accidents of geography going for it. It lay close to the surface in a great many places, and it lay close to navigable water, on the Tyne, the Wear, the Severn. London had been burning what it called sea coal, shipped down the east coast since the Middle Ages, and by 1700, the country was cutting somewhere around 2.5 to 3 million tons a year. Nowhere else came close. But the shallow seams go first. To keep up, you dig deeper, and below a certain depth, you are under the water table, and the pit fills. Horses turning a winch can only lift so much water for so much oats, and there were pits abandoned not because the coal ran out, but because the water won. So England had a machine that only paid on a coal field, and a coal field with a problem that machine solved. Between 1710 and 1733, 95 of them were built, almost all at collieries.
The standard answers to why Britain are all defensible, and none of them is sufficient on its own. Empire and the Atlantic slave economy supplied cotton and appetite. The settlement of 1688 gave secure property and a working patent system. There was a culture of practical tinkering, of instrument makers and public lectures that historians call the Industrial Enlightenment. Britain had coal, rivers, and no internal customs barriers. The trouble is the comparison. France had academies and superb engineers. The Dutch had property rights, capital, and literacy that Britain could only envy. China had enormous coal reserves in Shanxi, hundreds of miles from where the people and the workshops actually were. And the machines were not secret. Designs were published, copied, smuggled, and put on public show. A French manufacturer in 1780 could look at a spinning jenny, understand it in an afternoon, and have one built by the end of the month. Very often he did not bother. That is the fact that needs explaining, and it is not a fact about cleverness.
The economic historian Robert Allen took the obvious next step. He priced the machines. The spinning jenny, a hand-cranked frame that let one pair of hands work 8 spindles instead of 1, built by James Hargreaves in Lancashire in the 1760s, cost roughly the same to make wherever you made it. What differed was what it replaced. So Allen worked out the return on buying one, using local wages and local capital costs, in Britain, in France, and in India. In Britain, the returns come out somewhere between 24 and 59%. In France, low, and in most of his cases not worth the trouble. In India, where a spinner's day cost a small fraction of an English spinner's day, there was no case for it at all. The machine was not better in England. It was worth more in England because the labor it replaced was expensive there and cheap almost everywhere else. You have been told that the machines changed the world. It is at least as true that the world decided which machines were worth having. Now the part most videos leave out. Allen's argument is contested, hard, by people working on the same numbers. In 2011, 3 economists, Gragnolotti, Moschella, and Pugliese, went back through the Gini calculation in the Journal of Economic History, revised the assumptions about output and how much of the year a machine actually ran, and concluded that the Gini would have been profitable in France as well. Jane Humphreys and Benjamin Schneider went further. The people the Gini replaced were overwhelmingly women, spinning at home, and they were not well paid. Their conclusion is the precise inversion of Allen's. Mechanization was a response to low wages, not high ones. Judy Stevenson attacked the foundation itself. The famous London wage series come from building accounts, and building labor was hired through contractors who billed a day rate and kept a share of it. Somewhere between 20 and 30% never reached the man holding the shovel. Allen has answered all of them. Nobody has conceded. The high-wage economy is an open argument, not a settled finding.
2 places test the idea better than any argument does. The Dutch Republic had the highest wages in Europe, the best banks, the best shipping, and near universal literacy in its cities, and it did not get the revolution first. What it did not have was cheap coal. It burned peat, and peat is heavy, local, and finite, and by the 18th century, Dutch fuel was no longer cheap. High wages on their own were not enough. Then Cornwall, which had the opposite problem. Rich tin and copper, no coal at all, every ton of it hauled in by sea. Fuel there was dear. And Cornwall is precisely where James Watt's improved engine sold, because Watt's separate condenser cut fuel use by roughly 3/4. Boulton and Watt did not even sell the engines outright. They installed them and charged an annual premium calculated as a share of the coal the engine saved. Think about what that means. A business model that only works where fuel is expensive. The bad engine and the good engine were both priced by the same thing.
Which gives you the answer, or the best supported version of one. A new machine does not arrive finished. New Cummins engine was improved for 60 years before Watt ever touched it. John Smeaton simply measured everything, systematically, one variable at a time, and roughly doubled its efficiency, without changing the principle at all. But every one of those improvements had to be paid for by an engine that was already running, already earning, already being watched by people who could see exactly what was wrong with it. England was the only place on Earth where a machine that wasted almost all of its fuel could survive its own infancy long enough to stop being terrible. Not because anyone planned it, because the coal happened to be underfoot, and the water happened to be rising, and the wages happened to be high enough that a device replacing hands was worth its keep. By 1800, there were more than 2,000 steam engines in Britain. Fewer than 500 of them were Watts. The rest were still essentially New Cummins.
The Connegree engine is long gone. A working replica of it stands at the Black Country Living Museum in Dudley, not far from where the original drank its coal, and it still makes 12 strokes a minute. If you would rather have the argument historians are actually still having than the tidy version, that is what this channel is for. There is more of it here.